Hi Year 7, I'm here for another exciting maths video. Right, let's talk about a few things. Let's first talk about compound shapes. So we've done a little bit of this already. Let's just have another little look. I've got two shapes here. I want to find the area of this first shape. Oh no, it's a shape that I don't know a formula for. Hold on, if I use my logic skills, I can split this up into shapes that I can work with. So I can split here, there's a triangle, so half the base by the height. I can split here, another triangle, so we get the half base multiplied by the height of that. And then that is a rectangle on top, so I can get the area of that. Problem solved. That's called a composite or compound shape, when multiple shapes we know are put together into the one shape, and therefore we can find the area separately of 1, 2, 3 shapes and then add them together. So obviously the question you would have some units on this already and you could work it out. What about if there's a bit cut out from the middle of a shape? Well, that's the same, but we could do it using subtraction. So we found out the area of the small bit here in the middle and subtracted from the area of the whole thing, we would be left with just the area of the white bit. So subtracting or adding can be used when dealing with composite shapes. Okay, you just have to decide which one. Moving along, we're going to go 3D now, and we're going to go towards volumes of cuboids. What is a cuboid? Okay, well, this is a cuboid. This is a prism. So what's the difference? Well, cuboids is basically the rectangles or squares that have been three-dimensionalized. Whereas a prism is something that if you took a slice of it at any stage, it would be the same slice. So if you open that up at any slice, it would look like the front of it. Okay, so that a prism is like that. A cuboid is a type of prism that's based around a square. So if we slice this as well, it would also open up at the same point. That's very important when it comes to volumes, which we're going to look at now. Okay, so we should be able to get the area of the front of this cuboid, and then times width. So this area, 8 times 10, gives 80 centimeters squared. So there's 80 square centimeters in that front bit. But it goes back for 12 centimeters. How do I deal with this? Now you may have seen some formulas for volume before. That is length times width times height. Where does that come from? Well, it comes from the fact that those slices I talked about. If we look at any stage of this shape going backwards, it would have the same area at this front. If you cut a bit off, it would have the same area. Cut another bit off, the same area. And if you pile all those areas up on top of each other, then you'd have its volume by adding all those areas. Instead of making each slice and making thousands of slices and then adding the area, if you just know how many you need to take, and there's 12 of them, then you can just multiply by 12 instead of adding 12 slices in this case. So 80 centimeters multiplied by 12 would get the area. Might need a calculator. You could probably do it in your head. You got it? And it starts with 96 anyway, doesn't it? Because 12 times 8 is 96, and then the 0 from the 80, so it's 960. I'm going to change pen. I'm back. 960 centimeters. Well, centimeters what? If this is squared and you're times it by another dimension of centimeters, it's going to be centimeters times centimeters times centimeters, so that's cubed. 960 centimeters cubed. So let's apply it to another prism. Okay, finding the area. So I need to find the area once again of one slice, the front slice. Now this triangle is 6 centimeters wide at the base. Well, what's the height we used? Perpendicular height, remember? Not this slant height here, the perpendicular straight up height, which we have here. And it's 7. So what's the area of that triangle at the front? Half the base, which is 3, times 7, which is 21. So it's half of 6 times 7. So half of 6 is 3 times 7 is 21 centimeters squared. And that's the area of the triangle. I'm going to use a triangle symbol for short. Okay, so the area of the triangle is 21. Now how many slices of 1 centimeters do we have going all the way back? It's 20. So 21 times 20, because 20 centimeters here. If I multiply that by 20, I'll find out how many slices I get in my prism, and hence the volume, the third dimension. So 21 times 20, perhaps you can do this in your head. We'll make sure on our calculator. 420, let's remember the units. Centimeters cubed. Okay, so that's volume. Final thing we're going to look at today is surface area. So in a three-dimensional shape, there will be more than one surface. So you can see here on this cuboid or prism, how many surfaces do we have? Well, looking at it, we can only see 3 surfaces. But if we were to get something that's three-dimensional, we can see that there is more than 3 surfaces. We might be able to only see 3 at any one time. 1, 2, 3. But don't forget about the other side, 4, and the back, 5, and the bottom, 6. So this particular one has 6 surfaces. How can I draw that? Well, if that was the base, you could unfold a bit of it, and then unfold another bit, and then unfold one more time, and that'll be the 4 surfaces around the longer edge surfaces. 1, 2, 3, 4 underneath, and then we've 2 smaller end surfaces. 1 here, 1 here. So we can attach that to any one of these longer rectangles, and we create a net diagram. Now on a net diagram, we can use it to find the surface area. If we find the area of all these bits together, each bit by bit, 6 different areas, add them together, we get the surface area. Now in this unit, we got a little bit of a project to do. We're going to start on that next week. We need to know volume, surface area, composite shapes, how to get the area of composite shapes, and perimeter. And those things are all going to come up. So get balanced in the knowledge this week, and then next week we'll be applying it to some interesting stuff, along with accuracy and some real life issues that we could try and discuss. Okay? So we'll see then.